Far beyond the inner planets, the Jovian System awaits. Jupiter, visited in the past by some of the most important missions by NASA, like Voyager, Galileo, Cassini, and most recently Juno. Now, the attention turns to its moons, with ESA's newest mission. With more than 80 moons, 4 are considered largest and most important. Io, Europa, Callisto, and Ganymede make up the focus of the Jupiter Icy Moons Explorer, or JUICE. The first moons discovered beyond our own belong to the Jovian System. Discovered by Italian astronomer Galileo Galilei in 1610, they are called the Galilean satellites, though observations by other scientists of the time exist. The moons are perturbed by the massive Jupiter, which also enables their orbital resonance, in a 1:2:4 ratio between Ganymede, Europa, and Io. As it orbits Jupiter, Io, being closest to its magnetic field, is stripped of nearly 1 ton of material each second. The planet's material becomes ionized and forms a donut-shaped cloud of intense radiation, a plasma torus. Outside the torus, Jupiter's magnetic field is only slightly weaker. At Europa, the field was measured to be disrupted, perhaps by a Europan-induced field, brought upon perhaps by an electrically conductive fluid beneath the surface. Io is the innermost moon and the most volcanically active world in our solar system. Hundreds of volcanoes, some with lava fountains erupting miles in height. Europa is next, with a proposed iron core, rocky mantle, and what scientists believe is a salty ocean of water just beneath its icy surface, perhaps even a place for life. Ganymede, JUICE's main target and the largest moon in our solar system, is the only Jovian moon with a small magnetic field, auroras, and is thought to contain an ocean larger than that of Earth's under its surface. Callisto, farther than the rest, is thought to have the most craters of any object in the solar system. It was also detected to have a slight exosphere, and perhaps even a deep ocean under its surface. To send JUICE on its way, ESA's Ariane 5 rocket will keep the satellite in its fairing until reaching space. After lighting its main engine and its 2 solid rocket boosters, the Ariane 5 will see décollage, or liftoff, as it is carried away from the tower. As the rocket ascends through the clouds over Kourou, French Guiana, JUICE will begin its long journey towards Jupiter, leaving behind the Space Center and looking forward to new discoveries. An important mission for astronomers the world over, and a memorable second-to-last launch for Ariane 5. JUICE has now launched in April 2023 and is on its way for its first gravity assist around Venus in 2025. JUICE will spend its first 6 years waiting for the final gravity assist around Earth in January of 2029 to send it towards the Jovian System. It will then take another 2 years to slowly approach the gravitational influence of Jupiter and be among its targeted moons where science collection can begin. JUICE arrives in 2031 and moves on to complete at least 35 planned flybys of the icy moons at Ganymede, Europa, and Callisto. In 2034 and into 2035, JUICE will enter a tight polar orbit around Ganymede, focusing its 10 instruments on the icy moon. Throughout all of its travels and later science collection, JUICE would have extended its solar panels and antennas. Its instruments will also extend and begin testing themselves as the satellite travels through empty space. 3GM, or the Gravity and Geophysics of Jupiter and Galilean Moons, is a radio package comprised of the Ka transponder, ultra-stable oscillator, and high-accuracy accelerometer. The experiment will study the gravity field at Ganymede, the extent of the internal oceans on the icy moons, and the structure of the neutral atmosphere and ionosphere of Jupiter and its moons. GALA, the Ganymede Laser Altimeter, will study the tidal deformation of Ganymede and the topography of the surfaces of the icy moons. The instrument is expected to use its laser to cover the entirety of the moon's surface in 132 days. RIME, the Radar for Icy Moons Exploration, is an ice-penetrating radar to study the subsurface structure of the icy moons down to a depth of around 9 kilometers. PRIDE, or the Planetary Radio Interferometer and Doppler Experiment, will use the standard telecommunications system of the spacecraft, together with radio telescopes on Earth, to perform precise measurements of the spacecraft's position and velocity to investigate the gravity fields of Jupiter and the icy moons. It is important to note that the experiments on JUICE cover a wide range of the electromagnetic spectrum, from ultraviolet to visible to radio. The experiments can see Jupiter in different wavelengths, allowing for more scientific discovery. JANICE, an optical camera system, will study global, regional, and local features and processes on the Moon, as well as map the clouds of Jupiter. It will have a resolution of up to 2.4 meters on Ganymede and about 10 kilometers at Jupiter. UVS is a UV imaging spectrograph to characterize the composition and dynamics of the exospheres of the icy moons. It will also study the Jovian aurorae, and it will investigate the composition and structure of the planet's upper atmosphere. MAGIS is the Moon's and Jupiter imaging spectrometer. It will observe cloud features and atmospheric constituents on Jupiter and will characterize ices and minerals on the icy moon surfaces. SWI, the sub-millimeter wave instrument, will investigate the temperature structure, composition, and dynamics of Jupiter's atmosphere, and the exospheres and surfaces of the icy moons. JMAG, or the JUICE magnetometer, is set to characterize the Jovian magnetic field, its interaction with the internal magnetic field of Ganymede, and to study the subsurface oceans of the icy moons. The instrument will use flux gate sensors mounted on a boom. RPWI, or the radio and plasma wave investigation, is an instrument that will characterize the radio emissions and plasma environment of Jupiter and its icy moons. RPWI will be based on 4 experiments: Gandalf, MIME, Frodo, and GenRage. RADEM, or the Radiation Hard Electron Monitor, will provide information on the charged particle environment of the Jovian System, which will provide valuable information on the environment and its effect. PEP, or the Particle Environment Package, is a plasma package with sensors to characterize the plasma environment in the Jovian System. PEP will measure density and fluxes of positive and negative ions, electrons, exospheric neutral gas, thermoplasma, and energetic neutral atoms. Finally, in 2035, after completing its science objectives orbiting Ganymede, JUICE will make one final burn and set itself on course to collide with the icy moon. After a 12-year mission, multiple intergravity assists, and even more flybys of icy moons and a gas giant, JUICE will have completed its objective of further studying the Jovian System. In the new data to be collected by JUICE, we're sure to find tantalizing new details about the other worldly moons, and perhaps even find out if they contain the resources needed for life. Thanks for watching. If you enjoyed content like this, please consider liking, sharing, subscribing, and don't forget to turn on the notification bell to get more content from us as it's uploaded to YouTube.